Okay, Throwback Thursday for math. Our first box says Haley has 5 yards of fabric. She wants to make a costume for the spring carnival. She will need 160 inches of fabric. Use the table to find out if she has enough fabric to make her skirt. So, she has 5 yards of fabric. But for this particular costume, she needs 160 inches. So, yards, inches. We're not talking about the same unit of measure here. So we have to figure out how to convert inches to yards and yards to inches. And then we can figure out if she has enough material to make this costume. So they gave you a little graphic source there, a little table or a chart, okay? And it shows you right here that this column is talking about yards and this column is talking about inches. So just from looking at this chart, you should be able to tell that it takes 36 inches to make 1 yard. So now to fill in the rest of the table, if we have 2 yards of fabric, then we have 36 and another 36, right? So we could go ahead and figure that out. You could either do 36 plus 36, or you could do 36 times 2, because it's 2 yards, okay, which comes out to be 72 inches. So 1 yard, 36 inches, 2 yards, 72 inches. We follow that same pattern. So now if we have 3 yards of fabric, we're going to take that 36 inches and we're going to multiply it by 3, because you have 3 of those: 36, 36, and 36. So if we go ahead and work that out, that comes out to be 108 inches. So now let's go ahead and do 4 yards. So again, 1 yard is 36. And if you have 4 of them, 36, 36, 36, and 36, you would have 144 inches. And then the last one, following the same pattern. Now we have 5 yards. So 36 times 5, because it's 36 plus 36 plus 36 plus 36 plus 36, which gives us 180 yards. So now we have our table complete. We can go back and make sure that we answer the question that was asked. Use the table to find out if she has enough fabric to make her skirt. So she needs 160 inches to make the skirt. She has 5 yards. 5 yards is 180 inches. So she does have enough. She should have 20 inches left over, right? So yes, she has enough fabric. Don't forget that we're trying to make sure we're answering the question, writing it out into a sentence when we can. All right. Bluebirds use the branches of trees. Squirrels use the branches of trees. Use the word and to combine the 2 sentences above and rewrite the sentence. So those sentences can be joined together to make one sentence. We call that a compound sentence. A compound sentence is when you take 2 sentences that are separate, but you connect them together with a conjunction and make it into one sentence. Kind of like a compound word, right? We take 2 smaller words and we put it together to make one large word. Instead, when you're talking about compound sentences, you're taking 2 smaller sentences and combining them together using a conjunction. And the conjunction we're using here is and. Okay. We, as a writer, you want to combine sentences where you can, so that you're not just repeating the same thing over and over again. But then you also want to make some sentences larger and filled with more information and more figurative language, because it's better for your reader. But nobody wants to read bluebirds use the branches of trees, squirrels use the branches of trees. That's a little overkill. So why don't we just combine both animals, bluebirds and squirrels use the branches of trees. So now, instead of 2 separate sentences that basically says the same thing but a different animal, you put them together, make a compound sentence using the conjunction and. Bluebirds and squirrels use the branches of trees. Make sure your bluebirds is a capital B, because it's the start of your sentence. Squirrel is not a proper noun, it's just a little noun, so that does not need to be capital where you're combining it into this sentence. And then you're ending your sentence with a period because it is a declarative sentence or a telling sentence. You're telling somebody something. So this would be that compound sentence, 100% correct. All right. Draw obtuse angle UVW. We are going to start learning all about angles and plane shapes and geometry when we come back from spring break. That's going to be some of the new math material that we're going to work on over the course of the remaining days that we're on the shutdown. So we've touched on this. We haven't done the official lessons. We will, but we have touched on some of this terminology, and you should know some of it from third grade last year. So when you see something that looks like this, angle UVW, and we're going to talk about this basically on the first day after spring break. We have to draw an angle. Now, an angle are two line segments that meet at the same vertex, okay? And to make an angle, you're going to have three letters, okay? So I'm just going to draw an angle. This might not be obtuse just yet, but I'm just going to give you an example here. So here's one line segment. Here's another line segment, and they meet right here at this vertex. You can see it kind of makes it makes a V, a vertex, okay? So I can label this angle as UVW, okay? The 3 points is so two line segment points that come together and make the thing. Or I can even switch these two around and put WVU. As long as the letter that is in the middle of your angle is the point where your two line segments meet. Okay, this will always be your vertex, the middle letter. Okay, so we're going to draw that angle, but we need to make sure that the angle is obtuse. Now, when we talk about angles, there's three different types of angles that we have. We have an acute angle, we have a right angle, and we have obtuse angles. Now, the one that you should know right away is the right angle. The right angle looks like a perfect L. It could be upside down, it could be rotated, but it has this perfect 90-degree square right there in the middle. Okay? Now, an acute triangle is smaller than a 90-degree angle. Okay? So it's not going to have that perfect square here, okay? It's going to be 89 degrees or less, okay? So if you see this is the perfect L for a right angle, your acute angles are going to be any of the degree of angles as it goes smaller, as it starts to close, okay? So on the opposite end of that, an obtuse triangle is going to be larger than a right angle, larger than 90 degrees. You can see here, it's got a much bigger V or a bigger opening in the angle, okay? So this one is going to be 91 degrees or more. Those are your three angles. So if we go back to what we're doing, we have to draw an angle that is UVW, V being that center point where the vertex is, okay? And it needs to be obtuse. So we need to draw it bigger than this perfect L because it needs to be bigger than 90 degrees, okay? So as long as your angle, here's that perfect right triangle, as long as your angle is open bigger like that, you know that you drew it to be obtuse. So I'm going to go U, V, W. Okay, I got my V at my vertex, W and U. Remember, I could switch these around. I could put, W up here and U over here. It doesn't matter as long as the V is in the middle. And we can see that is bigger than 90 degrees, because 90 degrees would be straight up and down like that, right? But we need it to be bigger than that. We need it to be opened more. So this angle would be obtuse. And that's a nice little sneak peek of what we're going to be doing as soon as we come back from spring break. All right. Fraction Fun Friday. What amount does this model show? Write it in a fraction and in a decimal. So we have 3 squares there, and those squares have been broken down into 100 tiny squares. Okay. The 1 square, it's completely shaded in. So we have all 100 of those squares. So that there we have 1 hole, right? And the next one, we have another square broken into 100 little squares, and they're all shaded in. So we have another hole. And then that third one, again, it's a square broken into 100 other little squares, but not all of them are shaded. So we don't have another hole, we have part of a hole. So if you take a look, if that hole has been broken into 100 little squares, that's your denominator. How many of them are shaded is your numerator. So if you count them up, they go in strips of 10. So we have 10, 20, 30, 40, 50, and then 51, 52, 53. So this is the one box that's shaded. This is the next box that's shaded. And this is the third box that's only partly shaded. So if we add that all together for our fraction part, we have 2 holes and 53 hundredths. That's your mixed number or your fraction. Okay. Now we need to take this and turn it into a decimal. So remember what we said about decimals. Your whole number or your ones are going to go here to the left of your decimal. Then we're only learning 2 place values to the right of the decimal place. This one is called, and I hope you remember from last week, the tenths place. And the next one is called the hundredths place. There is no place value after the decimal. That's the once place. Okay, because you can't have part of a 1. So if we go back up here, we have 53 hundredths, right? So we want to make sure that we go all the way out here to our hundredths place. And you can never put 2 decimals in one place. So the only thing we could do is put our 5 tenths and our 3 hundredths. So 2 and 53 100ths shown as a decimal is 2.53, or how you would technically say this, 2 and 53 100ths. Okay. 6 and 8 twelfths minus 3 and 3 twelfths. Okay, so you could do this 2 ways. We could do it with this one because we could just go ahead and subtract our whole numbers and then go ahead and subtract our fraction part and have it come out completely. But just to let you know, if this was switched around, if it was 6 and 3 twelfths minus 3 and 8 twelfths, you can't do 3 twelfths minus 8 twelfths because you don't have enough. So we would actually have to turn these into improper fractions. And then we can subtract and then turn the improper fraction after we've subtracted back into a mixed number. But this one, we actually don't have to go that step because we could just go ahead and do it. So the first thing I want you to do is to pull out the whole numbers. For this one, our whole is 6 minus our whole number over here is 3. And that gives us 3 wholes. Now we'll take our fraction parts. 8 twelfths minus 3 twelfths equals 5 twelfths. So when we go ahead and put these together, your final answer would be 3 and 5 twelfths. And 5 twelfths cannot be simplified because there is nothing that you can divide 5 and 12 by evenly. So that fraction is the smallest that you can make it. Okay, so 3 and 5 twelfths is your answer. Write this number as an equivalent mixed number with hundredths. So 1 whole and 8 tenths. Okay. So if I was to show you that in a decimal form, it would look like this 1.8. Now, I can take this and turn it into a mixed number with hundreds. Okay. Keep our whole, but now instead of it being tenths, I want it to be hundreds. So remember when we do equivalent fractions, whatever you do to the bottom, you also have to do to the top. So that would make my new numerator over here 80. So 1 and 80 hundredths. And if I wrote that out, it would look like this. But now you can see that even though this is 8 tenths and this is 81 hundredths, this is the same decimal number. Okay? Just because there's a zero there, we're holding that place value, it's okay. But we can cover that up and it says the same exact thing here. So 1 and 8 tenths is the same as 1 and 80 one hundredths. And what is your current favorite song? Oh, geez. Favorite song, Bill? I don't know. I've been listening to a lot of Post Malone lately because I did go and see him on my birthday and I thought he was fantastic. Um, But my favorite song of all time is Imagine by John Lennon. If you've never heard that song before, I suggest you go on to YouTube and give it a listen. It's one of those songs that gives you hope and that this world will become the place that we've always imagined that it could become. If people just showed a little bit more kindness and a little more patience and a little more respect. So, with that, my friends, I'm signing off for spring break. Miss Hines and I miss you guys greatly. I'm going to keep the Google Hangout up if you guys want to go on there and talk. But just remember, the Google Hangout is considered a school platform, so I need to make sure that everybody on there is treating each other and talking as if they were in school, being kind, using kind language, no profanity, no pictures of anything that's not school appropriate. And who knows, Miss Hines and I might, jump on there at some point every once in a while throughout spring break just to say hello and to give a little check in on you guys. But after that, I will see you back on Google Classroom Monday, April 20th. And our routine is going to switch a little bit because where we're out indefinitely, I have to be able to start teaching you some new content, specifically angles and plane shapes and geometry. So exact path is going to be lessened. You'll still get on, but you won't have to do as many minutes every week. You're still going to be getting your green lights because that's just good practice. But I'm going to be teaching you new math material in the day and new language arts material in the day. They want us to start doing our stories of the week with our phonics skill and our vocab, just like we did in school. The cool thing is that they're starting us at the beginning of unit 5. 5? Yeah, unit 5. And no, unit 4. I have to go back and check my notes. I think we're doing unit 5. But anyway, you guys know that routine. So we'll be able to get everything fixed and stuff like that. Just make sure that you're checking Google Classroom, you're filling out your attendance form so I know that you're seeing your assignments and you're just doing those daily activities. If you follow along with those daily activities, you'll be, caught up with your work. You won't have to play catch up. And when it comes down to grades, I'll be able to actually say that you put in your participation and your effort and did what you were supposed to do. And I can give you a favorable grade. Okay. I love you guys. Have a safe and healthy and relaxing spring break. Bye.